All right, welcome ladies and gentlemen. This is the second video in the Liquids and Solutions unit. You are going to need your notes open to page 11 for this. Page 11, please. And in this we're going to be talking about table F, what compounds are soluble and which are insoluble, and something called precipitation reactions. And we're going to be taking a few notes with this in class, but not a ton, so we're going to be split between the video and class. You might also need your reference table. We have a table in our notes, but having your reference table open wouldn't be a bad idea either to table F. So this is table F. The title for table F is Solubility Guidelines for Aqueous Solutions. What does that mean? Table F is all about telling you what ions, if they're present in a compound, would make the compound soluble, and what ions, if they're present in a compound, would make the compound insoluble. Now this is kind of like table E, and if you remember with table E, when we're using table E, you're looking for only half of the name in table E, right? Table E isn't telling you the whole name for the compound. Similarly with table F isn't telling you if the entire compound is soluble or insoluble. You're kind of looking for half of the compound, and if it's there, how you're reading it, it's telling you if the compound will dissolve or if it won't. You're kind of splitting the compound up. So first of all, notice that there are 4 columns here that we're talking about. I'm going to start with the column on the left. Ions that form soluble compounds. These are saying that if these ions are present in a compound, then your compound will be soluble, i.e. it will dissolve, i.e. it will be aqueous, i.e. it will look like a liquid, right? It will look like a liquid. It's like, for example, group 1 ions. If you have a group 1 ion in your compound, then that will make the compound be soluble. That will make the compound dissolve in water. And we are talking about aqueous solutions, so we are talking specifically about dissolving in water. But then notice we have a column to the right of it called exceptions. Well, what does that mean? Exceptions to the will dissolve, meaning in this column, these are things that will not dissolve in water, i.e. instead of being aqueous, it would be solid. So notice that there are no exceptions for all these blank ones, meaning group 1 ions, if a group 1 ion is present in a compound, it will automatically make it dissolve in water, and there are 0 exceptions. It will work all of the time. But if we look down here for the halides, chloride, bromide, iodide, because they're all the way over on the left, it means that they will form soluble compounds. But we have some exceptions. So if we have silver, lead, or mercury 1, that's the mercury 1 ion. If any of those ions are paired with a chloride, a bromide, or an iodide, now it makes them insoluble. It falls into this category, right? This is insoluble. And then moving 1 column over, we have ions that form insoluble compounds. So again, this is kind of like looking for half of the name in table E. If you're having a compound and you find half of it in this particular column, ions that form insoluble compounds, that means that your compound will not dissolve in water. It's not soluble. It's insoluble. It's going to look like a solid. So carbonates, CO3 2-. These are typically very insoluble compounds. They don't dissolve in water. Likewise, chromates are insoluble. Phosphates are insoluble. Sulfides are insoluble, etc., etc. But then, again, going 1 column over, all the way on the right, we have the exceptions. The exceptions to the insoluble compounds. So these are things that are actually soluble when they're paired with the compound to the left of them. So these are things that will dissolve. And they will look aqueous. They will look like a liquid. So, for example, carbonates are insoluble. They do not dissolve unless your carbonate is paired with a group 1 ion or the ammonium ion. So we're going to practice with this in class because I know this is a lot to take in. We're going to take a few more notes on this slide, but that's the basics of it, and we'll come back to it. So what will dissolve in water? Again, what is this saying? Solubility ions, the ions, if present in a compound form soluble solutions, they will dissolve, right? We say for all those ones that are in soluble compound column. And then ions if present form insoluble solutions, it means they won't dissolve. But in each case, you always have to look at the exceptions. So for example, just a quick example sort of using table F, I have some compounds here. So lithium carbonate, Li2CO3, is it soluble or is it insoluble? You can approach this one of two ways, but you're looking for half. You're sort of splitting the compound up. You're not going to find the compound on table F, but you will find lithium on table F and you will find carbonate on table F. So it's sort of finding one of the two. And you can approach it one of two ways, like I said. First of all, you could find the carbonate, and you could see that carbonate is typically an insoluble compound. But then you check the exceptions, and you notice that group 1 is an exception for carbonate, which means it makes it soluble. It turns it from an insoluble compound to a soluble compound. Or you could just notice that lithium is in group 1, and notice that the very first thing listed in table F is that group 1 ions are always soluble. So this is very much a soluble compound. Group 1 ions are always soluble. There are no exceptions. Next up is lead 2 nitrate. Again, you're looking for half. You're looking for one of the two ions in table F. You're not going to find the two ions paired together. You're looking for one of the two ions. And the ion that you're probably going to find first is nitrate. I have this right underneath it, NO3. Notice that this is soluble, right? Ions that form a soluble compound. And there are no exceptions, none. Which means that this is a soluble compound. Lead is not an exception for nitrate. Next up is BaSO4. Again, you're looking for half of the name, half of the formula. Typically, it's going to be the second half. Typically, it's the anion. So you're going to usually not be looking at the first bit, but usually at the second bit. That's not always the case, but notice that the sulfates are down here. So sulfates are soluble. But now we check the exceptions, except when combined with silver, calcium, strontium, barium, and lead. Well, we have an exception here, and remember, the exceptions make them insoluble. So now we have a soluble ion, but we paired it with something that makes it insoluble. So now we have an insoluble compound. And last up is calcium sulfide. Again, you're looking for half of it. It'll typically be the second half. It'll typically be the anion. And over here, there's the sulfide. So sulfides are usually insoluble, but we have to check the exceptions. Is calcium an exception? Does calcium turn the sulfide from something that's insoluble to soluble? It says except when combined with group 1 ions or ammonium ions. Well, where's calcium on the periodic table? Is calcium in group 1 or group 2? Calcium's in group 2, so calcium is not an exception. So we are staying squarely in the insoluble column, and calcium sulfide is definitely an insoluble compound. What can we do with this? Precipitation reactions. Precipitation reactions use this idea of soluble versus insoluble. A precipitate is an insoluble product, i.e. a solid, that is formed from two aqueous solutions. So it's a solid that we get from two aqueous things. And we get a precipitate from a precipitation reaction. And the precipitation reaction is always going to be a double replacement reaction. Always, always, always. It's a specific type of double replacement reaction in which we get an insoluble compound. And it will always have the pattern of aqueous reactant plus aqueous reactant yields a solid product, and then another aqueous reactant, aqueous product. So that's our, I added in the additional product because it is a double replacement reaction. We will have two products. But we notice this pattern of soluble plus soluble makes insoluble, plus something else that's soluble. And that insoluble product, that is what we call the precipitate. right? A solid product from two aqueous reactants. We're going to take some more notes on precipitation reactions in class, look at some examples together, and we have a lab on that. So I'm actually going to stop the notes here, but be prepared to sort of grab your notes and write some more things down in class. So precipitation reaction, double replacement reaction where we're forming something that's insoluble. So that means we are going to be using table F, because table F tells us if things are soluble or insoluble. Table F will help us determine if we have an insoluble product.